Hey fellow problem solvers, Colfax Math here. Today we're working on our book, Math Test Success, Chapter 10, Linear Equations. We're going to do two different ways to solve these equations. The first is through substitution, and then the second is through elimination, and then we have a test at the end of the chapter. So if you have one variable, it's pretty easy to solve that equation. That was an earlier chapter. But now what we're looking at is two variable equations, otherwise known as systems of linear equations. Usually x and y are two variables. They usually represent a line like y equals 2x plus 5. And then I need a second equation like y equals negative 4x plus 8. And I'm really looking for where those two lines cross graphically, and that's going to give me an xy value. I'll talk a little bit more about that, but right now let's just talk about solving by substitution. So let's say right here I have a system of equations. It is called a system of equations because I have multiple equations. If I have two variables, I have to have two equations to solve. So if this is my first equation, y equals 2x plus 1, and this is my second equation, I can't solve them unless I somehow combine them. So again, two variables have to have two equations. Well, if I see that y is equal to 2x plus 1, I could take that value of y and plug it in for y to get 3x plus y. Well, I'm telling you y is 2x plus 1 is equal to 6. I have taken this value of y, substituted it into my second equation. Now I have one equation, one variable. Now I solve, just like we were doing in earlier chapters. 3x and 2x is 5x plus 1 equals 6. Subtracting 1 from both sides, 5x is equal to 5. Dividing both sides by 5, x is equal to 1. And then now that I have that value for x, I am not done. I need to take that value for x and plug it back in to either equation to solve for y. So if x is 1, I could plug it back in there. I have 3 times x, which is 1, plus y equals 6. 3 plus y equals 6. Y is equal to 6 minus 3, or 3. I have a value for x, a value for y. That is called an ordered pair. The first value is always x. The second value is always y. If I were to graph those two lines, they would intersect at that point 1, 3. Okay, here are a couple of practice problems right here. Pause the video, do these two problems, unpause the video, and watch how I do them. Starting out pretty easy so we get the hang of systems of equations, and we'll progress to harder and harder problems. Okay, on number 1, y is equal to 3x. I take that value, plug it in there. X plus y, which is 3x, 4x. 4x is equal to 8. Divide both sides by 2. Divide both sides by 4. X is equal to 2. I have that value for 2. Take that, plug it in there. 2 plus what equals 8? Which is 6. So I have one value of 2 and then 6. I could always check my solutions by plugging it in. Again, first value is always x, second value y. 2 times 3 is 6. Y would have to be 6. It works there. 2 plus 6 is 8. It works there. Let me move this up a little bit. Actually, here are a few more practice problems as well. So number 2. A is equal to this. Take that value and plug it in for A. So 3 times A, which is 2B, really? 2B minus 1. So that's 3 times whatever A is, plus B is equal to 11. One key thing here is I have to remember to distribute that 3 through the quantity. So I got to multiply it all the way through to get 6b, 3 times 2b, minus 1 times 3. plus b equals 11. 6b plus 1b is 7b. I add 3 to both sides. 11 plus 3 is 14. Divide both sides by 7, and b is equal to 2. Only half my answer. I have 3a plus b, well, b is 2, is equal to 11. Subtracting 2 from both sides, 3a is equal to 9. A is equal to 3, 9 divided by 3. Value for b, value for a. I could write it as an ordered pair, or I could just leave it as b is equal to 2, a is equal to 3. Sub them back in, make sure they work. Here's another problem. I think I'll skip 3. Let you do that on your own. Then jump down to number 4. The sum of two numbers is 25. So whatever those numbers are, I don't know. So I call them a variable, x plus y equals 25. One number is 5 more than the other number. So the two numbers together have to be 25. And then one number is 5 more than the other number. Now that I have that, I could take that value for y, plug it in for y, to get x plus y. Well, y is now x plus 5 equals 25. 2x, combining similar terms, subtract 5 from both sides, is equal to 20, 25 minus 5. Divide both sides by 2, x is equal to 10. It's not my answer, it's only half my answer. When x is equal to 10, what is y? So I plug that 10 in here. 10 plus what equals 25? Y is equal to 25. Now that I have my solution, my ordered pair, 10, 25, x first and then y, see if it holds true. The sum of two numbers is 25. Something's wrong. Oh, I did that wrong. X plus y equals 25. That's exactly why you check it. This is wrong right here. This is wrong right here. Let me do this in blue. Hopefully you didn't turn off. Sum of two numbers is 25. One number is 5 more than the other. Find the two numbers. So all this is correct. I take that, I plug it in here. 2x is equal to 20. X is equal to 10. I am saying x is equal to 10. 10 plus what equals 25? It has to be 15. So y is equal to 15. Let me check if that works true on here. The sum of two numbers is 25. Yes. One number is 5 more than the other. Yes, that is true. Actually, let me go back and do number 3 as well, because this one's a little trickier. I don't have y by itself, so I have to solve for y first in terms of x. So on this one right here, I'm going to subtract 2x from both sides to get y is equal to 7 minus 2x. I subtract 2x, 7 minus 2x. So I have a value for y. Take that value for y and I plug it in here. So I have that original 3x minus 2 times whatever y is. 7 minus 2x is equal to 0. One equation, one variable. I could solve that now. Need to distribute first, then combine similar terms. 3x minus 14. Then I got to do this too. Plus 4x is equal to 0. 3x and 4x is 7x. 7x minus 14 is equal to 0. Add 14 to both sides to get 7x is equal to 14. X is equal to 2. Have that value for x. Plug it into either equation. Solve for y. I think I'm going to plug it in there. 3 times x minus 2 times y is equal to 0. 6 minus 2y is equal to 0. Subtract 6 from both sides. 0 minus 6. Divide both sides by negative 2. Y is equal to negative 6 divided by negative 2. Negative divided by negative is positive. So I have a value for x, value for y. Double check that. 3 times 2, 6. Minus 6 is 0, works there. 4 plus 3 is 7, works there. My solution, the ordered pair, is 2, 3. All right, a lot going on there. Hopefully that made some sense. We're going to do some more problems in the test. Let's move on to solving by elimination. So the first thing you want to do is you want to align the equations, multiply both sides of the equations, add or subtract to get one of the terms to drop out, solve the equation for the remaining term. Once you have that value of x or y, that term, plug it back in to either equation to solve for the other term, and then always check. So here's an example. Here's a set of systems of equations. I have two equations right here. I want to line them up so that something will drop out and cancel. 2x plus 3y equals 8. 1x plus minus y equals 1. Nothing there will cancel, but they are aligned. But if I multiply that second equation, so I have 2x plus 3y equals 8, I need to get rid of the x or the y. I think I'm going to multiply this thing by 3. X minus y equals 1. I'm going to multiply both sides by 3. And I'm going to do that so that my y's will cancel. So in red up here is my first equation. Right here is my second equation. I do whatever I want to the equation as long as I do it equally to both sides. I'm going to multiply both sides by 3 to get 3x. Remember, distribute through the quantity. Minus 3y is equal to 3. I have done that so that I could cancel out those y's. Now I'm just going to add those two equations together. 2x, 3x is 5x. 3y, negative 3y is 0. 8 and 3 is 11. From there, I divide both sides by 5. And x is equal to 11/5. It's not working out to be too easy. It's a fractional answer. Now that I have that value for x, I could plug it into either equation. I think I'm going to plug it in the second one. Doesn't really matter. X, 11/5 minus y is equal to 1. I'm actually going to call out 1 5/5. That's the same thing as 1. Okay. Then I'm going to subtract 5/5 from this side. Add y to both sides. These are going to cancel. 11/5 minus 5/5 is 6/5. These cancel, and I have y is equal to 6/5. My ordered pair is now fractional. X is 11/5. Y is 6/5. And that's my solution. Let me double check that. X is 11/5 minus 6/5 is 1/5, which is going to work in that equation. In the second equation, I plug 11/5 in there to get 22/5 plus 3 times 6, 18/5. Add across the top, that's going to give me 40/5. 40 divided by 5 is 8. So I can see that one works in both equations. Okay, here's some practice problems here. We want to line these up. See what if we have to multiply. This first one's pretty easy. I'm just going to put that x minus y, that equation there, just right there. So I just move that over there. They are nicely aligned. I don't have to multiply. My y's are going to drop out. I'm going to add those equations together. X plus x. Negative y and y is 0. 10 and 2 is 12. divide both sides by 2, and x is equal to 6. Take that value of x, plug it into either equation. Right there, I have 6 plus y is equal to 2. Y is equal to 2 minus 6, negative 4. Solution's an ordered pair, x, y. This one's going to line up pretty well too. I just draw this out there. My b's will cancel to give me 5a is equal to 15. So in this one, 5a is equal to 15. A is going to equal 3. Plug it back in and solve. On number 3 here, I'm going to multiply because they're not going to line up. So, oh no, they are. That 3y and the negative 3y will line up, so I don't have to multiply. I was going to multiply this one by 2 to get rid of the x's, but they're going to line up. So I have negative 2x plus 3y is equal to negative 10. I add straight down. 4x minus 2x is 2x. My y's cancel. 6 and negative 10 is negative 4. Divide both sides by 2, and x is equal to negative 2. I have that value for x. I could take it, plug it in either equation. I think I'll plug it in there to give me negative 2 times x plus 3y is equal to negative 10. That means the bell's going to ring. I'm going to run out of time. So negative 2 times 2 is 4 plus 3y equals negative 10. Subtract 4 from both sides. 3y is equal to negative 14. Y is equal to negative 14 thirds. Value for x, value for y. My ordered pair is negative 2, negative 14 thirds. Take that, plug it back in. Let's see if this is going to work. 4 times x, which is negative 2, minus 3 times y, negative 14 thirds, should be equal to 6. This right here is negative 8. This right here, negative times a negative is going to be positive. My 3's cancel. Negative 8 plus 14 should be equal to 6, and it is. So there's my solution, and I've checked it. Next step is this test on Chapter 10, Systems of Linear Equations. You could do it with some of them by substitution, some of the problems by elimination, and then I have a couple of word problems at the end here. All right, after you've paused the video, taken this whole test on your own, I'm going to run through it right now. Take some notes of your own. So solve by substitution. Here's a value for y. I take that value for y and plug it right in there. So I have that 2x plus y. Well, y is 3x minus 1, and that is equal to 9. Combine similar terms. 5x is a 2x plus 3x. Add 1 to both sides. 5x is equal to 9 plus 1. Divide both sides by 5, and x is equal to 2. That's not done because it is a ordered pair as my solution of both x and y. So I take that value of 2, and I want to plug it back in. Either equation, doesn't matter which one. I'm going to plug it right in there. 3 times 2 is 6. 6 minus 1 is 5. So y is equal to 5 when x is equal to 2. And again, that is an ordered pair, x first and then y. So my solution is 2, 5. Okay, next problem right there. Move it up a little bit here. Again, we're solving by substitution. This time I have x is equal to this. Take that value for x, and I'm going to plug it right in there. I want to use my parentheses here. 3 times x, which is 2y plus 5, minus 4y is equal to 17. I've taken the two equations through substitution to create one equation, one variable. Now I'm going to solve for y. Important part, especially like on an ASVAB or military exam, you got to remember to distribute that 3 through the whole quantity to give you 6y, 3 times 2y, plus 3 times 5, 15, minus 4y equals 17. Combining similar terms, 6y minus 4y is 2y. Subtract 15 from both sides. 17 minus 15 is 2. Divide both sides by 2. Y is equal to 1. I'm going to take that value of 1, plug it back in either equation, but it looks like it'll be easier here. Then x is equal to 2 times y plus 5. 2 plus 5 is 7. My ordered pair is 7, 1. And that's my xy value. Okay, let's do the next one also by substitution. Y is equal to negative x plus 4. I'm going to take that and plug it in here for y. So I have 2x minus 3 times y. Remember to use parentheses here. Negative x plus 4. And then that is equal to negative 2. I'm down to one equation, one variable. A couple of important things here is I got to really remember that negative to distribute through that whole quantity. So I have that 2x, negative 3 times the negative x, negative is positive, 3x, negative 3 times a positive 4, negative 12 is equal to negative 2. Hopefully you went through a lot of those previous chapters on distribution, solving equations. I'm going to combine similar terms, 5x. Here I am subtracting 12. To get rid of it, I add 12 to both sides. Add 12 to both sides, 2 plus 12 is 14. Divide both sides by 5. These cancel, and x is equal to 14 fifths. It's a lot trickier one here. So now I need to solve for y. Y is equal to negative x. Negative x is 14 fifths plus 4. Well, I have to have a common denominator to add or subtract fractions. So I'm going to multiply, this is over 1, so I'm going to multiply it by 5 over 5 to get that common denominator. This is 20. 20 and negative 14, 20 and negative 14 is 6 over 5. So my x value was at 14 over 5. You could just leave it like that. And my y value is 6 over 5. Really a pretty hard problem, putting a lot of our skills from previous chapters to work here. Okay, let's go to number 4. This one's a little trickier because now I don't have y or x by itself. I could do this a couple different ways. I could get this y by itself, or I could get that x by itself. Either way will work. I think I can get the x by itself, and I'm going to subtract 2y from both sides. So now I have x equals 1 minus 2y. X is equal to 1 minus 2y. I'm going to plug that in for x here. Again, remember I have 4 times the quantity x, 1 minus 2y. That's just that part. Then I have the minus y is equal to negative 13. Remember the distribution here. 4 minus 8y minus y equals negative 13. Again, kind of same process, combining similar terms. Negative 8y and y is negative 9y. Divide both sides. No, I don't. Subtract 4 from both sides. So I got this negative 8y minus 1y. That gave me that negative 1y. Subtracting 4 from both sides gives me negative 17. Divide both sides by 9, negative 9. These cancel. That gives me y by itself. This is 17 ninths. Not that easy, 01. And then from there, I'm going to take that y value and plug it into either equation. I don't think it matters which one. I think I'll plug it into the top one right here. X plus 2 times 17 ninths is equal to 1. 1 is the same thing as 9 ninths, right? That's my 1. Here I have x plus 34 ninths equals 9 ninths. Subtract 34 ninths from both sides. That'll cancel. And I have 9 ninths minus 34 ninths is at negative 25 ninths. So I have value for x, negative 25 ninths. That's my value for x. My value for y, 17 ninths. So there's my solution, my ordered pair, my x, my y. Okay, number 5 here, solve the following system by elimination. That means I'm going to add or subtract. I could do that right away without modifying them. I could just add straight down and my y's will cancel out. 2x and 3x is 5x. Y and negative y cancel. 7 and 3 is 10. Divide both sides by 5. X by itself, x is equal to 2. Have that value for x, plug it back in. I'll plug it into either equation. 2 times x plus y equals 7. 4 plus y equals 7. Subtract 4 from both sides. Y is equal to 3. I have a value for x, 2, and a value for y, 3. There's my ordered pair. I could always take those values, plug them back in and check. X is 2, 4 plus 3 is 7. It works there. 6 minus y, 3. 6 minus 3 is 3. Works in both cases. Okay, down here in number 6, I can no longer add and subtract because nothing's going to cancel. I could do whatever I want as long as I do it to both sides of the equation. I think I'm going to get rid of the x's. I could do this a lot of ways, but I'm going to get rid of the x's. I'm going to take this left side and multiply by negative 2. I could do that as long as I do it to the right side. So I have that original equation right there. 4x plus 3y is equal to 10. Now I'm going to multiply that negative 2 through that whole left side to give me negative 4x, negative 2 times negative 5y, positive 10y is equal to negative 6 times negative 2, 12. My first equation just transposed right there. My second equation, multiplying both sides by negative 2. And then now I could add those two equations together, and my x's will drop out. 4x plus negative 4x is 0. 3y and 10y, 13y. 10 and 12 is 22. Divide both sides by 13. Y by itself, and y is equal to 22/13. I take that value of y, plug it into either equation, solve for x. My solution should be an ordered pair. Working with fractions again. Let me keep going. I want this video to get too long here. This problem number 7, I do it similarly. I think I would multiply the top equation by positive 2, both sides of the equation. That'll give me 10x minus 4y equals 24. And then I'm going to add the two together to get those y's to drop out. Then once I do that, I'll have one equation, one variable. I'll be able to solve for that variable and solve. do just a couple of word problems. Again, the key's right here for you to check. This whole book is available. I figured out the best way to do it is I built a web page called Math Test Success. There's a link to it. Just go to Math Test Success. I just made it all free. You just click on the download link, download the book. You can print it all out. I am going to make it available so you can buy it on Amazon. My kids told me just to make the whole thing all open source and free, and if people wanted to donate, they could, so that I could keep doing these videos and making them accessible to more people. Okay, let's do number 8 here. The sum of two numbers, so that means I'm going to have my x and a y. Sum of two numbers is, remember that's equals 25, and their difference is 7. So x minus y, that is difference, and their difference is 7. I could do this two ways, right? We talked about substitution. I could solve for x, plug it back in, then solve for y. But in this case right here, I can see with elimination, it's going to be a really easy way to do it. I'm just going to add the two equations together to get 2x. My y's cancel is equal to 32. Divide both sides by 2, and I get x is equal to 16. I take that value of x, plug it into either equation. 16 plus y equals 25. Subtract 16 from both sides, and I get y is equal to 9. Again, this is an ordered pair, x, y. And let's just double check that. 16 plus 9 is 25. 16 minus 9 is 7. So it works in both cases. If you get that problem, you're really making a lot of progress. This thing really incorporates a lot of the previous chapters. It's pretty tricky. Last problem, number 9 right here. A movie theater sells tickets for $8 for adults, so I have adult, and $5 for children. So I'm going to call A adults, C children. The total of 120 tickets, that means A plus C has to be equal to 120. A is the number of adult tickets, C the number of children tickets. The revenue was $780. So $8 adult tickets, $5 children tickets. So that means 8A, $8. Waiting for my pen to catch up here. $8 times the number of adult tickets plus the amount of the children's tickets times how many there are is equal to 780. This one I could do linear combinations as well, but it might just be as easy to do substitution. So this one, linear combinations worked well. This one I think I'll do substitution. You don't have to, multiple ways. No one is right on that as long as you follow the rules of algebra. So what I'll do here is I'll subtract C from both sides, and I'll get A is equal to 120 minus C. I'm going to take that value for A and plug it in here. So it's going to go there. So that's going to give me 8 times A, 120 minus C, 8A plus 5C equals 780. Again, I got to distribute here. 8, 960 minus 8C plus 5C equals 780. I'm going to subtract 960 from both sides. 780 minus 960, I think, is negative 180. 8, 960. And that is equal to negative 3C. Dividing both sides by negative 3, I get C by itself, and C is equal to 60. So I have a value for C. So that means 60 plus adult plus what equals 120. So adults are also 60. Let me double check that. 60 times 8 is 480. 60 times 5 is 300. 300 and 480 give me my total of 780 there. It was a pretty hard test here. Hopefully you did well on it. There are the answers. I really appreciate you watching. Hopefully we're kind of doing this together, getting ourselves back on track to do well on all future math and any standardized exam. If you're new to the channel, hit that subscribe button and also notifications. Check out the book. I appreciate you. Thank you for watching.